So I'm going to take the number 6, and I'm going to divide it by, let's see here, create a slider. We'll go from 2 to 4.01. All right, so let's talk about this idea here. If I take 6, okay, and I divide it by, so what I'm going to do here, I've taken this value of 6, I've forced that to be constant, and we're going to divide it by this value d right now, okay? And when I change d to any number that I want, okay? I'm just going to go between 2 and 4, but it doesn't matter what I'm going to. I'm looking at, let's look at this number right there, that value e that I'm getting. As I move, so I want to ask you, what is 6 divided by 3? It's 2, okay? And the reason for that, one of the reasons for that is as I move this value here, okay? So this number is getting closer and closer to 3 as I move it from the left. Does that make sense? Okay. This here is 6 divided by that number. So as I approach that number from the left, okay. So right now, 6 divided by 2.21 is this number right here. Okay. 6 divided by 2.43 is this number right here. Do you see that number, as that 2.47 number is getting closer and closer to 3, what is this number getting closer and closer to? It's getting closer and closer to 2, right? Now it's at 2.1. This is really close to 3. Let's get even closer. Okay, this is getting closer to 2. We see it's dropping, right? Okay, so as I get to the value, so at 2.99, okay, I'm there. That E value is that, and I get to 3. What's it jump to? Straight down to 2. You guys okay, everybody? So as I divide take 6 and divide it by numbers that are less than 3 but very, very, very close to 3, that quotient starts to approach that number there from the left. Does that make sense? But let's say that I divide by numbers that are bigger than 3. So let's start over here at 4. And I take 6 divided by 4, it gives me 1.5. Okay? Take 6 divided by 3.77, it gives me 1.59. What is happening to that number E as this number D gets closer and closer? Okay, it's getting bigger. So the closer that gets to 3, that number is now going from 1.88 to 1.89. Now it's at 1.95. And eventually, it gets to 2. Does that make sense? So what are we seeing? We're seeing as I take a constant value like 6, and I start dividing it by numbers that are approaching 3 from the left-hand side, that quotient turns into 2, right? As I divide from values that are approaching 3 from the right-hand side, so like 3.1, 3.01, 3.001, that quotient is approaching 2. So because they're approaching the same 2, we can say that 6 divided by 3 is 2. Does that make sense? Okay. Now, why do I talk about that? Because now the question is, well, what if I want to divide by 0? That's what we've been told we're never allowed to do, right? But never really talk about why, okay? I'm just going to highlight, so the idea in that last picture was that the image was just a horizontal line. Bring that back up here. As that point B was moving, it was horizontal, right? Okay. And from, if I trace, as this gets closer and closer to, as this number here gets closer and closer to 3, we see, oh, I went too far. Do it from this side. As we get closer and closer to 3 from this side, we're seeing that quotient gets closer and closer to 2. Okay, and the same thing if I move from the other side. If I ask about division by 0, so now what I'm going to do on here, all I've done is I'm graphing, I'm taking the number, so let's hide some of this stuff. I don't need that anymore, and I don't want that anymore. Okay, so now all I'm doing is instead of having those two values, so this number right here is actually, click on it, it's 2 divided by whatever this is. Okay, so 2 divided by this number. Okay, if I take this number and I start making it like 0.84, so 2 divided by 0.84 becomes this number here. Does that make sense? Okay, this 0.84 number is getting closer and closer. I want it to get closer and closer to 0. Does that make sense? Okay, and this is just plotting then what the y value, what that quotient would be. Okay, so as I trace this, so basically each one of those little dots there is saying that that is, in this case, this dot right here is an a value of 0.77. If I take 2 divided by that, I get this y value of 2.59. Okay, so what I'm asking here is, what does that number, as this gets closer and closer to 0, as a gets closer and closer to, lowercase a gets closer and closer to 0, we're starting to see that y value shoot up very far. Okay, so it starts off there, but now it's getting closer and closer in this direction. It shoots off up to, right now we see it's at 20, but if I can make it go even slower, now it's up to 20.02. Okay, keep going. It's going to take a little bit of time. What is happening to that 25 number, 27 now, 28, 30? What's happened to that number? The closer and closer this thing, this value of a gets to 0. It's getting bigger and bigger and bigger, right? Okay. So if I take a number and start dividing it by something that is very small, any number, and divide it by something that's very small, now what's that number all the way up to? 384, right? Okay, let's see how far. So now, 0.0006. Now it's up to 3,333. The idea is that there's really no bound, okay, because now, obviously, this is going to go to 0 next when I click it, but I could create this and say, go out more decimal places. That number's up at 20,000 now. The idea is that as I get closer and closer to dividing by 0, that quotient is going to infinity. Does that make sense? Okay. So what happens then if I jump to the other side of 0? The same thing kind of happens, but now we're going down to negative infinity. Does that make sense? Okay. So what we see then is if I divide a number by something very, very close to 0 on the right-hand side of 0, the quotient goes to infinity. If I divide by 0 from something that is to the left of, very, very close to the left of 0, the quotient goes to negative infinity. Because those two numbers, negative infinity and positive infinity, are not the same, we can't divide. We can't say that we know what the quotient is when we divide by 0. Does that make sense? Where when we did 6 divided by 3, we knew that the quotient, when we were moving from the right-hand side of 3, we got close to 2. And from the left-hand side of 3, when we were dividing by something very close to 3 on the left-hand side, the quotient was 2. So because the 2's were the same, we would say 6 divided by 3 is 2, right? Does this kind of make sense? Okay. So that's one reason why we can't divide by 0, because we don't know what that would be. Okay, and the idea is that we say it diverges to either positive infinity or negative infinity. Based on another rule, and this one's easier to realize. Okay, if I take a number like 15, and I divide it by 3, what does that give you? Gives you 5. Okay? That means that 3 times 5 equals 15, right? Okay. So if I take 15 divided by 0, and that gives me a known number, I'm just going to call that known number n. That would mean okay, just going through the same pattern here, it'd be 0 times n, 0 times, because this went 3 times 5, right? This would be 0 times n equals 15, right? Does that make sense to everybody? Okay. But what do we know that 0 times n should be? 0 times n should give a result of 0, right? Okay. It's also, because of our rule of multiplication, we know 0 times anything is 0. This would be what we call a contradiction to that rule, and that would then be the reason why we can't divide by 0. Does that kind of make sense? Okay. I think you've always been told, just don't do it. But those are 2 reasons why, or 2 proofs, and they're not really proof. We didn't go into a whole lot of detail in writing our proof, but that is the logic of why we cannot divide by 0. Okay. Why do I talk about that? If you remember on Thursday, we were talking about domains of functions. Okay. And we want to make sure that we realize when we are done with adding, subtracting, multiplying functions and dividing, that we know what can be put into those functions. And one of the main rules that we have to abide by is that we're not allowed to divide by 0. Okay, so when you're done, you got to make sure that you kick out all values that would produce division by 0. Okay, so that's a domain concern. Another domain concern is that we cannot take square roots of negative numbers. Okay, and eventually we'll even expand that to saying we can't take even roots of negative numbers. So you can't take the square root of like -10, and I can't take the 4th root of -10. I can't take the 6th root of -10 because those are even roots of a negative number. Okay, when we're talking about an even root, we're talking about multiplying something by itself an even number of times, and that should always produce a positive number. Therefore, if I'm asking what number can I multiply by itself 4 times to get -10, there is no such number that does that, because 4 negatives is a positive. Okay, so they're going to ask us to create some functions. They're going to ask you to add them, subtract them, multiply them, divide them, and then talk about what their domains are when you're done. Okay, those 2 things we have to keep in mind. So as we do this question, it says find the functions f plus g, f minus g, f times g, and f divided by g, and their domains. First thing I want to do is figure out their domains first. Okay, so I'm going to write it this way. Let's just say we write D for domain, and then we'll put like a subscript of f to refer to this function here. Okay. Okay, what x value can you not use in this problem because it would make you divide by 0? If I look at that, what x value could you substitute in there that would make that bottom 0? We can do it this way. We can say Whenever you get a fraction, you take the denominator and you write that statement, okay? When I put the equal sign and that slash through it, it says x minus 2 cannot equal 0. Does that make sense? Even though it's a not equal sign, we're still going to treat this like an equation and solve it for x. So what would I add to both sides to solve for x here? 2. So right there I'm saying x cannot be 2. Does that make sense? Okay, so that's my domain. So that's the only thing that gets kicked out. So a couple different ways of writing this. Okay, we could say the domain is all real numbers except 2. Okay. Let's just leave it that way. Let's write it that way for now. Okay, so a lot of times they might write it a little bit more concise. They might say this is like the more formal way. They'll say x, and they'll put a little e here, and that stands for element. They'll say all real numbers. That's the symbol for that phrase right there, all real numbers. So it says x belongs to or is an element of all real numbers. And then they'll put like a semicolon here and then just say x cannot be 2. So it says it can be anything but 2. Okay? I don't want to get into right now with you all the formal notation of how we write different arguments like this, but right now, do we at least get the idea that x cannot be 2? Okay? If I look at g of x, okay, g of x, so the domain, I'll do this in a different color. Domain of g, okay, because it's a square root, all we have to do here is we take the radicand, okay, we have to say that we can only take square roots of 0 or positive numbers. And the reason we can take 0 is if I put 0 underneath the radical, and I ask you what two numbers multiplied by, or what number multiplied by itself twice will give you 0, it'd be 0 times 0, right? You can answer that question with 0. So what we do here is that we just take whatever this is, whatever this symbol is down here, this variable, or this variable component, the radicand, and we say it has to be greater than or equal to 0. And those are our two domains. Okay. Is that all right with everybody? Okay. Now, when we go through and we're asked, can you find what f plus g, what f minus g, what f times g, and what f divided by g look like, and then their domains, I'm going to write it this way, the domain of f plus g, f minus g, and f times g. Okay, all the ones that involve operations that are not division. The division one's a little bit different. The domains of all of these are the overlap, if you want to think about it as the intersection of the domain of f and domain of g. Okay, so what we do is we take, I think this is the easiest way to decide this. You don't have to draw a picture, but I think pictures are best. I'm going to draw the domain for D in red. Okay, so I'm going to put on my number line. Basically, all I'm going to do on my number line is find the key points. They said 0 and 2 are the key points that were in those domains. So I'll just put 0 here, and I'll put 2 there. If you remember back to early on when we were graphing solutions like this, if something was excluded, something was not allowed to be an answer, we put an open dot on it. So 2 cannot be an answer, cannot be an x value for this domain. So I'm just going to graph in red everything that's allowed to be an answer. Okay, or maybe not an answer, but it's everything that I'm allowed to plug in to that function 1 over x minus 2. The open dot says that's the value that you're not allowed to plug in. Does that kind of make sense to everybody? So just graphically showing that statement, x is an element of real numbers, but x cannot be 2. This is the visual of that, okay? If I want the visual of the g function, its domain, I'm going to go find 0, and its equality, it's greater than or equal to, so I'm going to close that in. I'll make it a solid dot. Okay, hopefully you guys remember doing that stuff earlier in the year. And now x is bigger than or equal to 0 would be all that stuff, right? Okay with everybody? So now, how could I verbalize, how could I write the overlap of those two domains? What would you say in words that my overlap would be here? Where do they start overlapping? If I read it left to right, where do they start overlapping? Start overlapping at 0, right? So I'm going to say x is greater than or equal to 0, okay? Is there any spots over here where they don't overlap? Do they both, remember what that open dot means? It means there's a gap there, right? Okay, so do they overlap there? No, okay? So I would say they overlap when x is greater than 0, except for when x is 2. Okay? If I was, the way we would write that, there's an easier way of writing this. It's just time consuming and learning how to do it. It's called interval notation, where I just say, okay, what's the first value that they overlap at? And I write that down. And I go up to the next value that they stop overlapping at. They stop overlapping at 2, and I write that down. I put a bracket around that one, and that, you guys remember back to graphing, we either use dots or brackets. Okay, so this bracket means the same thing that closed dot meant. Okay, if you remember open dots paired up with parentheses. So I'm going to kick 2 out. That's what that basically means. And then I'll group that. I'll jump across 2. And I'll write something like that. And basically all that means is that my domain, and they're going to ask you to answer this in a little bit more of a cleaner, easier way in Math Excel. But basically it's saying that the domain of all of these functions that we end up coming up with here in a little bit the only x values you're allowed to use in plugging in will be 0 to 2. You can include 0, but you're not allowed to use 2. And then everything bigger than 2. Does that make sense? Okay. So when they ask us what is f plus g, okay, I'm just going to give myself a little bit of room here. When it says f plus g of x, all we're doing there, remember we said that is f of x plus g of x. All we're doing is grabbing these two things, cut and paste, and then putting a plus sign between them. So f was 1 over x minus 2. We're going to add to it g, which was radical x. In the domain, so that's a new function, okay? In the domain of that new function is everything from 0 up to, but not including 2, and then everything after 2. And why does that make sense? Well, it has to be bigger than 0. Let's choose a number like negative 10. If I put negative 10 in here, it gives me a number back. It gives me 1 over negative 12, right? That's a number. That's a real number. But if I put negative 10 in here, it's going to spit back undefined. There is no number that I take the square root of and I get a negative 10. So I would have negative 1/12 plus undefined. And if I ask you, well, what is that total? You can't tell me that total, right? Does that make sense? If I said I'm thinking of a number, add 7 to it, none of you are going to get that total because you don't know the number that's in my head, right? Okay. It's undefined. So that's why we had to choose numbers bigger than 0. If I choose a number like 2, I could take the square root of 2. Square root of 2 is about 1.4 something. Okay? But over here, If I put 2 in, it's 1 divided by 0, and that's undefined. So it's the same logic. I don't know what that total would be because that's not a defined value. So when I ask for this domain is this right here. X has got to be bigger than or equal to 0, but it cannot be 2. Okay. If I want to go f minus g of x, it's f of x minus g of x again. So f of x, 1 over x minus 2, minus g of x, radical x. You just basically cut and paste the two functions you're adding or subtracting together, put them down, and then your domain is that domain we've already found. Does that make sense? Okay. Now we could do, and we're not going to. I do very little of this even with my my road students. We could make that one fraction if we wanted to, common denominator, all that kind of stuff, but usually it's not necessary. Okay. Let's go f times g. F times g. So look like that, which just means we take f of x, and we're going to multiply it by g of x. So that's going to give me 1 over x minus 2, and we'll multiply it by square root of x. And you can leave it that way, but usually we do simplification with multiplication. We do, because it's a fraction times a fraction. So you're going to multiply straight across the top, 1 times radical x, and then straight across the bottom, x minus 2. So that would be f times g. If we did g times f, it would be the same thing. Multiplication is commutative. And again, as long as x is not 2, if x was 2, you'd have radical 2 divided by 0, right? You can't divide by 0. If x was like negative 5, you would have square root of negative 5, which we don't know what that number is, divided by negative 7. Well, if I don't know what the number is, I can't divide it by negative 7. So that's why the domain here still has to be bigger than 0, could be 0, and not 2. The last one is a little bit trickier, like f divided by g. Okay, what we do here, we take our function 1 over x minus 2, and we're going to divide it then by g, which was radical x. Okay. Now, the domain is still the same exact thing as before, but we got to make sure that because we're doing division now here, before we were allowed to take the square root of 0, correct? But now if I take the square root of 0, and use 0 as an input, I would get 1 over negative 2, and I'll divide that by the square root of 0 is 0. Can you take negative 1/2 and divide it by 0? Are you allowed to divide by 0? No. So in this last one, you always got to make sure there's always one extra kind of confirmation of division. Can I divide this by 0, or is there any time that this would be 0, and I would end up dividing by 0? In this case, there would be. So my domain would still be x. You remember earlier, it's x is greater than 0, greater than or equal to 0, but x could not be 2. Now, we're going to say x can just be greater than 0, which tells us that it cannot be 0. Does that make sense? Okay, and that would be the domain of that function. Now, generally, we won't type an answer in like this because that's kind of messy looking. Does anybody remember how to divide a fraction by a fraction? If I have 1/2 divided by 2/3, anybody know how to do that? What do I do with that number? I flip that number and multiply it by the top. So that would give me 3/4. Does that make sense? Okay. So it's the same thing here. Remember, these just represent numbers. We just don't know what they are. So I'm going to take that bottom fraction, radical x over 1, and we'll flip it.
period class will report to her classroom as usual today. All other classes will report to study hall for the rest of the day for Mrs. Beckman. Again, fifth period, you will report to the classroom. Thank you.
So when we do that, okay, we get that final graph there. Or not graph, but function. And if we were looking at the graph, that graph, and this is how I would check to make sure that I've done this correctly, that graph there, if I type that in, should look exactly like if I type that one in. If I go G over F, so this is a little bit different. G over F, that would be radical X divided by 1 over X minus 2. Okay. And now here's the issue with this. This is the type of problem that we get problems with. Now, what that means is radical X, that's that fraction. 1 over X minus 2 is that fraction. If I take this fraction here, right now, X cannot be 0, correct? Or sorry, X cannot be 2 because that would give me division by 0 down here. Does that make sense, everybody? Okay. So I'm not allowed to have X to be 2. When I multiply here by this reciprocal, that's the function that I'm left with. And when I'm left with that function, it doesn't look like there's any division, right? So it looks like I could use X to be 2, but I want to graph these things real quick to show you. If I have, so if F of X equals 1 over X minus 2, that's that graph, okay? If I go G of X, which equals square root of X, that's that red graph, okay? Remember what we were doing, if I do division, okay, of these two things at like some particular number like 4, I'd be plugging 4 in here, be plugging 4 in here, and then dividing those values. Okay, but if I look at just what F divided by G looks like, F divided by G, you see there that if I put in, so this gives me this new function, which means if I put in H to be 2, because we said 2 is not part of our domain, we're not allowed to use 2. See how it gives me this number? It gives me infinity back, which doesn't really make sense because infinity is not a number, it's an idea. Okay, so that would tell me it's undefined. If I plug in H of 0, I get negative infinity back. That's an idea. It's not a number. So that tells me in that situation, okay, and that's what we came up with, right? 1 over X minus 2 over radical X. But we said X was not allowed to be 0 in that case because when I plug in 0 to right here, it gives me back negative infinity, an undefined value. Okay? If we did G divided by X, it looks like that. G divided by X looks like that function right there. Okay? Oh, I messed that up. I didn't want G divided by X. I wanted G divided by F. Sorry. And it looks like this. Now, it didn't simplify it. Okay? It did not simplify it. But if I ask what P of 2 looks like, okay, it gives me a result, and this is actually an error in GeoGebra. It should not give me back 0. Okay, let me see if Desmos will. Sometimes we get little glitches with GeoGebra with the quotient line. So if I go square root of X divided by 1 over X minus 2. Actually, I got to make those A's. And then I say A, I want to be 2. Still going to do it. All right. We'll talk about this in more detail tomorrow. But because I can, because of the composite function, I'm still not allowed to use X to be 2, even though these programs are showing that produced. Do we get the idea? Do we get the idea of just adding, subtracting, multiplying these things? Just grabbing them, putting the operations between them and having at it.